Hi everyone, Khalid is here, and today I'm gonna introduce our brand new tool which called SuperAligner. So let's get started. First, what is sequence alignment? Sequence alignment is the process of comparing and detecting similarities between biological sequences. This helps us to identify regions of similarity that may be a consequence of functional, structural, or evolutionary relationships between the sequences. Now we need how many type of alignment. Actually, there are only two type of alignment. First, pairwise alignment, which is only between two sequences, and multiple alignment for three or more sequences. By using more than one algorithm to build up a tool that combines the pairwise and multiple alignment algorithms in one place to make the alignment easier. And that's how our aligner tool come to life. So let's test it up. First, let me show you the manual of the tool and how to use it. As we can see here, here's a bunch of options we can use with the tool. Here's dash H for help. It will bring the manual as we can see here. Dash Q for quality chart. It will display the sequence quality score chart. And dash Q score chart for displays the rate of gaps, mismatch, and match between the result of sequence. Dash T for translator, and it will translate the DNA sequence to a corresponding protein. Dash is for Smith-Waterman algorithm, and this algorithm is for local pairwise alignment. Dash N for Needleman-Wunsch algorithm, and that's for global pairwise alignment. Dash B for progressive, and dash I for iterative, and both of these are for multiple sequence alignment. And dash F here if you want to provide the sequence in a file in FASTA or FASTA file, and we just need to enter the path of the file here. Dash is if we want to provide a sequence by hand, and dash Q to give a corresponding a quality of a corresponding sequence. Now let's start testing the tool, and we will start with the dash N for global alignment. But before that, I should mention that some of these options are mandatory, like we must specify the algorithm that we will use, and we must specify the method that we will use to provide the sequence. So let's start with dash n. Here, dash n for Needleman-Wunsch algorithm, and I will provide the sequence in a FASTQ file. So I will write dash f, and I will give the path of the file. Press enter. And as we can see, here's the result of the two lead or two sequence. Let's take a look of this file here. We have the first sequence here, and we have the second sequence here, and here's the global sequence alignment between these two sequences. Now let's let's provide the dash q option and dash g option and see what will happen. As we can see here, it gives us the score quality, a chart of score quality of the sequence, and it gives us the rate of gap and mismatch and match. He told us that we had 10 gaps for mismatch and about 70 matches. Now let's provide dash T and see what happened. And here it gives us the corresponding protein of each sequence of this. Now let's test the dash S for Smith Waterman algorithm for local alignment, and I will provide the sequence by hand just like this. I'll provide the same sequence in the file, so I will take it as a copy paste here. First sequence, and here is second sequence. Let's enter, and as we can see, here is a local alignment between these two sequences. Now let's test the multiple sequence alignment, and we will start with dash B for progressive alignment. We will provide the file which contains the sequences, and it's here. It's in FASTA file, and press enter, and here is the multiple sequence alignment between the sequences in the file. Sorry for that. If we enter dash I, it will give us the result of iterative alignment of these sequences. And if we can look at this file here, here is the file that contains the sequences that we do the multiple alignment to it. Now that's a super alignment tool. And finally, because of what happened this semester, our tool is under development and it's not ready for production yet. Thank you very much.